All right, number 41, integral of theta times tangent squared theta d theta. These problems are going to get more challenging from here on out. So if you're able to do these or you're able to struggle through them, that's a really good sign for your exam because I'm assuming that your instructor won't give too many if you're in a typical like community college or university and give too many of these difficult ones. Maybe one or two, but they have to set the curve properly. Anyway, okay, so this one, immediately I'm seeing that it's a product of two things. So maybe integration by parts is what I would want to do. Okay, because I don't see a substitution that will help me here, at least right from eyeballing it. It's not fully a trig integral. There's a theta here. There's a tangent squared, but there's a theta there as well. I don't want to do a trig stuff for sure, not in this, and this is definitely not partial fraction decomposition. Okay, so if I do use integration by parts, what would I let my u and dv be? Or maybe I should change this guy to secant squared minus 1. Maybe that will help me out, actually. Okay, remember that trig identity, Pythagorean identity? Okay, so once we do that, we have theta secant squared theta minus theta d theta. Okay, so this I'll leave alone. The next guy will just be half theta squared. Okay, plus c, we can write that now. All right. So now we got to evaluate this. Now this one's a bit more nice to choose by u and dv. I'm going to do up here. U is theta. Du would be d theta. Then dv is secant squared theta, d theta. That's what's left. What's v? It's just tangent theta. Okay. So this is theta tangent theta minus integral tangent theta d theta. And then we have this minus half theta squared plus c. And then what's the integral of tangent theta d theta? Hopefully we remember that. If not, you can just change the sign of cosine and do a substitution. Okay, it is ln of secant theta. Okay, or you might remember as minus ln of cosine theta, or it's the same thing as plus ln of secant theta. Okay, and then minus half theta squared plus c. Here's my answer. Let me double check this is matching what I had previously. Looks like it to me. Yep. Okay. So again, you might be able to just do integration by parts directly from the beginning. I thought just to do secant squared minus 1 instead of tangent squared because this was a more obvious integration by parts for me. And then integrating theta is easy. That's just the power rule.